Welcome to this explainer. Today, we are diving into a really fascinating framework that completely solves a massive headache in the world of artificial intelligence. It's called Duty Distinct Chain of Thought, or DDCoT for short. If you've ever worked with an AI that has to handle both text and images at the same time, you already know that things can get a little, well, messy and unreliable. But this framework cleans up that mess brilliantly.
So let's kick things off with a pretty wild question. Why do incredibly smart AIs still hallucinate visual facts? It's bizarre, right? You have these highly capable, state-of-the-art models, yet when you give them an image and ask a simple question, they will sometimes confidently invent details that they absolutely cannot see. It is a huge roadblock when it comes to making multimodal AI truly trustworthy.
Here is our roadmap for today. First, we'll cover the multimodal hallucination problem. Second, divide and conquer reasoning. Third, the four-step DDCoT process. Fourth, overcoming previous code challenges. And finally, putting DDCoT into practice. Part 1, the multimodal hallucination problem.
The stakes here are incredibly high. Think about it. If we can't trust what an AI tells us about a basic image, we definitely can't deploy them in the real world for critical tasks. When AIs are forced to process text and images together simultaneously, they often just fall back on what they know best, which is text-based guessing. It is literally like a brilliant bookworm suddenly being asked to perform visual surgery. Instead of carefully analyzing the visual pixels, the model leans on its massive text training data and just assumes what should be there. The result? Highly confident, yet entirely fabricated answers.
Which brings us to the formal definition. Multimodal hallucination is the phenomenon where an AI generates incorrect factual statements by inappropriately blending textual assumptions with unverified visual inputs. Basically, the AI is trying to be a reader, a logical thinker, and a pair of eyes all at once, and it just trips over its own feet. Moving on to Section 2, divide and conquer reasoning. Okay, so how do we fix this? Well, we need to stop asking one generalist model to do absolutely everything. DDCoT relies on two really core insights. First, keep critical thinking alive. The AI has to maintain a healthy dose of skepticism and actually admit when it's uncertain. And second, let everyone do their jobs. We absolutely have to divide the labor between specialized models. Think of this division of labor, which is the duty distinct part of the name, like a highly specialized human team. On one side, we have the large language model. Let's call it the analyst. Its job is pure logic. On the other side, we have the visual question answering model. That's the scout. The analyst shouldn't sit in a tent and just guess what the scout is seeing out in the field. Instead, the analyst needs to formulate specific questions and send the scout to actually go look. All right, Section 3, the four-step DDCoT process. This sequential framework is exactly where we operationalize that analyst and scout dynamic. First off, instead of tackling a complex prompt head-on, the LLM breaks the reasoning down into smaller, logical sub-questions. Second, it uses negative space prompting to identify which questions it actually needs eyes for. Third, the visual recognition model steps in to answer those specific questions. And fourth, the LLM executes a joint reasoning integration to deliver the final, polished output.
Let's zoom in on step 2 for a second, because honestly, the exact prompt snippet used here is a total game changer. It literally says, formulate the corresponding sub-answer as uncertain if the sub-question cannot be determined. By explicitly giving the LLM permission to say, I don't know, we create negative space. This is huge because it prevents the LLM from filling in the gaps with its own hallucinations. It completely forces the analyst to wait for the scout.
Section 4, overcoming previous caught challenges. So the philosophy sounds great, right? But does it actually work in practice? Listen to this stat. 25.3%. That is the massive reduction in factual errors when you use the DDCoT framework compared to standard prompting. Just by dividing up the labor, an entire quarter of factual errors simply vanish. And right on the heels of that, we see a 28.1% drop in overall hallucination rates. That's no accident. That is the direct result of using that uncertain negative space prompting we just discussed. By separating the duties and actually acknowledging what it can't see, the AI simply stops making things up.
When you stack DDCoT up against previous multimodal chain of thought methods across rigorous human evaluations, it is an absolute blowout. Relevance jumps from about 71% up to 92%. Correctness goes from 68% to over 86%. And explainability, which is how well we can actually understand the AI's underlying logic, skyrockets from under 59% to over 83%. But you know what might be the biggest operational win here? Flexibility. Previous multimodal methods required really labor-intensive and costly manual annotation just to train the models on how to reason. DDCoT achieves these high-quality rationales in a zero-shot manner. That means it works brilliantly right out of the box on totally novel problems, without needing any expensive training data. Finally, Section 5, putting DDCoT into practice.
So how do we actually tie the analyst and the scout back together at the end? The crucial point is found in the final integration prompt. It explicitly tells the LLM, please note that the supplementary information given may not always be valid. Please select valid information to form the rationale. This part is absolutely fascinating. We are instructing the analyst to remain critical of the scout. The LLM actively filters out bad data, validating the knowledge to construct a rock-solid final answer.
If you're looking to actually implement this in your own workflows, the framework relies on standardizing the input. You just need to pass in specific placeholders to your prompt template. Things like the text context, a true or false flag for whether an image is present, the core question, and the available options. It's a really highly systematized, plug-and-play approach. So what's the big takeaway from all this? It's pretty clear. By dividing labor, letting language models reason while vision models recognize, and by intentionally embracing uncertainty through negative space prompting, DDCoT brings us so much closer to a truly accurate, human-like multimodal understanding. It essentially replaces blind guessing with actual structured thought.
We've seen just how incredibly powerful it is to give an AI permission to say, I don't know. So my question for you is, how will you use negative space prompting in your own AI workflows? Think about the hallucinations you could completely eliminate today just by giving your models distinct duties. Thank you so much for joining me on this explainer. I really hope you found it as fascinating as I did.